polynomial. So we have this polynomial right here. First thing I want to do is find what are my possible roots. So plus or minus factors of 6 over plus or minus factors of 1. And that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And all of them over 1 still just gives us this. Now that's 2, 4, 6, 8 different factors that I need to try. And there's no guarantee that they're going to work. So what I'm going to start doing is using synthetic division, like we learned in the last section, and see which ones, when I divide them, divide evenly. So trying 1 first, we have the coefficients here. We have 1, 2, negative 5, negative 6. Bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 5 plus 3 is negative 2. 1 times negative 2 is negative 2. And we know that this is already not going to work, because if this divided evenly, this would be a 0. So this one doesn't work. Now let's try negative 1. 1, 2, negative 5, negative 6. And now we have the 1 coming down. Negative 1 times 1 is negative 1. 2 plus negative 1 is 1. Negative 1 times 1 is negative 1. Negative 6, 6. Hey, this one works out nicely. Our remainder is 0. That means that x plus 1, because a minus and a minus is a positive 1 here, x plus 1 is a factor. And what's left is, this is our x squared term, our x term, and our constant, so x squared plus x minus 6. And that's this polynomial here factored. Well, we have one factor, and rather than using synthetic division, I know how to factor this. I know that this is equal to x plus 1, and then this polynomial here is going to be x plus 3, x minus 2. And you can use the x method or whatever method you like for factoring. So what I know from this, since this polynomial right here is equal to this, my roots are x equals negative 1, x equals negative 3, and x equals 2. Okay. So those are all of my zeros. We found all of them. Let's look at the next example here. Now we have this polynomial here, and we want to look at what our possible roots are. Well, we've got the factors of 3 over the factors of 1, and that's going to be plus or minus 1, plus or minus 3. So we've only got 4 of them here to try. And rather than wasting your time with ones that I know won't work, we're not going to try 1 and negative 1 first. This time we're going to try 3. So our coefficients are 1, 7, 11, negative 3. Bring down the 1. And then 3 times 1 is 3. Adding is 10, 30, 41. And already I can tell this is going to be way too big. That one's not going to work. So let's try negative 3. 1, 7, 11, negative 3. Bringing down the 1, negative 3, 4, negative 12, negative 1, 3, and this one worked. So that means that the polynomial that we originally had is equivalent to x plus 3, and then x squared, x, and minus 1. And I know that I can't factor this using the x method. It's not going to work. So what I can do is use the quadratic formula. We know another way for solving something like this if factoring doesn't work. So I'm just going to start a kind of answer box over here. I have x equals negative 3, and I know I should have 2 more because my degree is 3, so that tells me that I need to have 3 answers here. So using the quadratic formula, x is equal to my negative b, which in this case is 4, so negative 4 plus or minus square root of b squared, so 16 minus 4 times a times c, over 2 times a. Now simplifying this, I have negative 4 plus or minus the square root, and a negative times a negative is a positive, so I have 16 plus 4 is 20 over 2. And I know 20 is the same thing as 4 times 5. So I know that I can pull something out of here. I have -4 plus or minus 2 root 5 over 2. I can simplify here, and I get x is equal to -2 plus or minus root 5. So then my two answers here are -2 plus root 5 and -2 minus root 5. So those are my three solutions. So just going through those steps again, we listed out what our possible roots are. We tested the ones to find which one worked, and then we solved what was left over to find all three roots. We're going to go ahead and flip the page now. We've got one more example here. And I'm going to show you guys another method instead of synthetic division. So for this this next example here, we have this polynomial, and I have 24 here. Now I'm going to look at the roots or the factors of 24 over the factors of my leading coefficient, which is 1. And this is going to be a lot of them. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. All of those numbers go into 24, and all divided by 1 still just give me this. Now, rather than testing all of those, because that would take a lot of time for us, and dividing with synthetic division on all of those, what I can do is I can figure out what is f of x when we find f of 1. What about f of -1, f of 2, f of -2, and so on. And I can find all of those all the way down to f of 24 and f of -24. And what that does, and we looked at this at the end of last section, is if it's equal to 0, if these are at all equal to 0, then I can say, well, that means it's a factor. So plugging in 1 into this function, plugging in 1, I get 1. Plugging in 1 here, I get -6, and then -8, and then plus 24, and that's not equal to 0. And plugging in -1, I get 1 minus 6 plus 8 plus 24, and that's not equal to 0. But plugging in 2 here, I get 16 minus 24 minus 16 plus 24. Now these two cancel and those two cancel, and that's equal to 0. And that's a good thing for us because that means that x equals 2 is a factor. So we can divide using synthetic division, 1, and then we don't have an x cubed term, so 0, minus 6, minus 8, 24. And dividing using synthetic division, we get, bring down 1, 2 times 1 is 2, 2, 4, -2, let's see, -4, -12, -24, and just like we said, it divides evenly. So now we have x minus 2, and this is our constant, our x squared, our x cubed. But now I've got this whole thing to factor still. So I know that 2 worked, and then I could go through this whole list and see what other ones work. But we have a problem, because I can tell you right now, all of these are not equal to 0. So that means we don't have any other roots here, and we don't have any other roots here. This was the only one that worked. But it's possible that we could have 2 factors of x minus 2. It's possible that x minus 2 divides this still. So let's try dividing by 2 again. And we're dividing this now. So my coefficients are 1, 2, -2, -12. Bringing down the 1, 2, 4, 8, 6, and 2 times 6 is 12. And it divides evenly again, which means we have another copy of this x minus 2. So we have our original x minus 2 here. And then when we divided this, we've got another copy of x minus 2. And then what's left over is x squared plus 4x plus 6. Now, this, I can tell you right now, is not going to be factorable using our normal factoring methods. So what we're going to need to do then is use the quadratic formula again. So I've got x equals negative b, so negative 4, plus or minus the square root of 4 squared is 16, minus 4 times a, which is 1, and c, which is 6, over 2 times a. And simplifying this, we get negative 4 plus or minus the square root of negative 8 over 2. Now, seeing this negative 8 right here tells me that I'm going to have an imaginary root. So I can rewrite this. We know 8 is the same thing as 4 times 2. So negative 4 plus or minus 2I root 2 over 2. We can simplify, and we have negative 2 plus or minus I root 2. So when I'm writing out all 4 of my roots, because my degree is 4, that tells me I should have 4 answers. I have x equals 2, x equals 2 again, so we had 2 of those. And then from this polynomial right here, we got x equals negative 2 plus I root 2, and x equals negative 2 minus I root 2. And those are our 4 solutions. Now, the very end of our notes here, I'm going to go ahead and finish on another video. So I'll go ahead and end this one here, and that's part 1, and then we'll start part 2.